Multiplying binomials is a very common algebraic concept as you move forward in your algebra courses. And it would lead you on into the calculus courses as well. As you find certain zeros of a polynomial, you will be looking to use factorization. Factorization is built from the idea of multiplying together polynomials. Because again, later on when we start talking about factorization, factorization is a way to think about um, the opposite of multiplying. So it's kind of like dividing out factors. Multiplying binomials here, we're going to look at the typical FOIL method that is used to gather this idea. But let's go ahead and look at this here. It says to multiply two binomials, you can use both the left and right forms of the distributive property. Typically, we see the left distributive property. That's what we've been using thus far. When we distributed the monomial negative 5v, it was on the left side of our polynomial. Therefore, that's invoking the left distributive property. If that factor, that lonely monomial factor, was on the right side of the polynomial, we still can distribute it to each term in the polynomial in our parentheses. We would just be doing so from the right-hand side. And luckily for us, multiplication is commutative. It doesn't matter. It's going to give us the same outcome. So for example, if we have a binomial product here, and we treat one of the binomials as just a single number, then we can kind of consider taking a binomial and distributing it to each term within another polynomial. Let's go ahead and take a look. You see here for the product of 3x minus 2 and 5x plus 7, we do have a binomial 3x minus 2 multiplying a binomial 5x plus 7. Think about what our terms are. The terms in our first binomial, positive 3x, negative 2. The two terms in our second polynomial, positive 5x, positive 7. So as we distribute the 3x to each term in the second polynomial, you get that first equality there. That's the mentality that we're doing there. We're going to take the 3x and we're going to multiply it to both the 5x and the positive 7. But we also have that negative 2 that we must distribute to the 5x and the positive 7. So thus we are using the distributive property twice. Because we have two terms in our first binomial, we must distribute each of those two terms respectively into our second polynomial using multiplication. So as you see there, multiplying together two terms with two terms, we end up with four terms, 15x squared plus 21x minus 10x minus 14. But as you see, after we multiply together these two binomials, we end up with four terms that are unsimplified. This is not a four-termed polynomial because it is unsimplified. The two terms in the middle, positive 21x, negative 10x, each have degree 1. Notice that x is understood to be to the first power. We have 21 x's, but we're taking away 10 of them. So this four-termed polynomial simplifies down. Positive 21 minus 10 to give us 11. We get 15x squared plus 11x minus 14. Now again, this idea here can be formulated by our FOIL method. Off to the right-hand side, we see there that any binomial a plus b, just in general terms, notice we had the 3x and the negative 2, but those numbers are of course to change as you see number 40. Any binomial a plus b multiplying to any binomial c plus d. We are going to start by multiplying the first terms together. We will multiply a times c. We will then look to multiply a times d. That is taking care of distributing a to the two terms in the second polynomial. Then we will look to distribute b to c, and then distribute b to d. So you see how we get the acronym FOIL, product of the first terms, product of the outer terms, product of the inner terms, product of the last terms. For number 40, perform the multiplication and simplify. So here we have 8x minus 6, multiply 5 minus 4x. We'll go to the full screen. The parentheses are setting next to one another. So that indicates that we are multiplying. And thus, when we multiply a polynomial to a polynomial, we want to make sure to distribute each term in the first polynomial. We want to make sure to multiply to each term in the second polynomial. So our first product here, 8x distribute to the 5. That's our first product. Our second product is 8x, which again, our 8x is positive, right? So a positive 8x will multiply negative 4x. We've now distributed this 8x to each of these two terms. So we will move on to the minus 6. The minus 6 distribute to 5. Lastly, the minus 6 distribute to minus 4x. And when we distribute, we are using the operation of multiplication. The 8x distributes to 5 under multiplication. The 8x distributes to the negative 4x under multiplication. Distributed property, you are distributing, you are multiplying some number, some monomial, some polynomial here through to another polynomial using the order or using the operation of multiplication. So we have our first term here. Here's our plus sign. Here is multiplication. So this is our second term. And the second term was founded multiplying the outers. Our inner product gives us our third term. And the product of the last two terms, here's the last term in the first polynomial, the last term in the second polynomial. That product here is the L for FOIL. So our job here is to look to simplify. Well, 8x times 5. 8 times 5 is 40. Multiply our factor of x. This gives us 40x. A positive 8x multiply a negative 4x. Well, a positive times a negative is negative. 8 times 4, 8, 16, 24, 32. X times x. Now again, this negative 4 here, we're not going to multiply an x and a negative and get another negative, right? Positive 8 times the negative 4. That negative now is here. So we have x times x, which is x squared. Negative 6 times 5 is negative 30. Negative 6 times negative 4x, negative times negative, positive. 6 times 4, 24. Multiply this factor of x. That's a positive 24x. So again, when we use FOIL, this is our first term, this is the outer term, this is the inner term, and this is the last term. Right? We get this from the product of first terms, product of outer terms, product of inner terms, product of last terms. Are there any terms up here that can combine with one another? 40x plus 24x. How many x's do we have? We have 40 x's. But now we're going to add 24 x's to them. So overall, how many x's do we have? 40 plus 24 is 64. So we have 64 x's. The 64x, that is a positive 64. So now writing our newly simplified polynomial in the standard form with the largest exponent x squared out front, the minus 32x squared is negative 32x squared plus 64x minus 30. Where our degree of the polynomial is 2, the leading coefficient is negative 32, and our constant is negative 30. Our second problem there is the binomial 7x minus 3 but that's being squared. What do we mean there? This is a common mistake for a lot of students, and I hope that we do not make this mistake. When you have these two terms in here with the exponent out front, this does not allow you to square this term and square this term. A lot of us will write here 49x minus 9 or plus 9 or some jabber. Please don't do that. Because what this tells us is we have some number that's being squared. What do we know about exponents? This represents repeated multiplication. This number, 7x minus 3, is multiplying to itself twice. There are two factors of 7x minus 3. What does that look like? Well, this is one factor of 7x minus 3. Here are two visual factors of 7x minus 3. The quantity 7x minus 3 squared is simply the product of 7x minus 3 and 7x minus 3. We are multiplying together two binomials. So this binomial squared, some of us might end up with something like 49x squared minus 9 or plus 9. That's a binomial. When you square this binomial here through the FOIL, we will see you will end up with a trinomial. Let's go ahead and find out what that looks like. The product of the first terms, 7x, multiply 7x. What's 7x times 7x? 7 times 7, or 7 squared, is 49, but x times x, x squared. Multiplying the outer terms, 7 times x times negative 3. 7 times negative 3 is negative 21 with this factor of x, negative 21x. We've multiplied the 7x to everything over here. Let's move on to this negative 3. We will start by multiplying the negative 3 to the positive 7x here. So this is the product of our inner terms, FOI. Negative 3 times positive 7x. Once again, negative 3 times positive 7 is a minus 21 with a factor of x here, minus 21x. But notice that we get the same thing here for these two terms. That's going to happen every single time. We're going to see later on that this is actually a special factor. This is the square of a binomial difference. We have a binomial subtraction, so there's a difference. Square of a binomial difference. Every time this happens, if you have a square of a binomial, these two middle terms in the FOIL method will always end up being exactly the same. Negative 3 times positive 7 is negative 21x, and you're going to get that twice here because this is a special product. It's going to happen every time. Lastly here, negative 3 times negative 3, the product of our last two terms. Well, a negative 3 times a negative 3 is positive. 3 times 3 is 9. So negative 3 times negative 3, or in other words, we could write this as some number negative 3 squared. Remember, when you square a negative number, negative 3 times negative 3, that results in a positive value. And in this case here, it's positive 9 for the constant of our polynomial. We do the FOIL method. We end up with four terms, FOIL. Can any terms be simplified? And notice more often than not, when you have these nice looking binomials such as 5x plus 2, 3x minus 7, when you multiply those to other binomials that fit that same form, ax plus b, these two middle terms are typically going to combine for us every time. We just have to check and make sure that their degrees are the same. X is to the first power, x is to the first power, therefore the degrees are same. We'll combine the coefficients. Minus 21, minus 21. If I'm already below 0 at minus 21 and I take away 21, I'm going to get even smaller. So if I double minus 21, what is 2 times minus 21? What is, right? I have minus 21x 2 times. Verb that, write that down. Minus 21x 2 times. 2 times minus 21x, minus 42x. So we have here our simplified, look at this nice trinomial here. Later on in chapter 6, we will start with this trinomial and we will find ways to factor this into the product of two binomials. So right now in chapter 5, we start with multiplying and we get a result. In chapter 6, we're going to be given this result and we want to know what are the factors that make up this polynomial. What multiplies to give us this? Well, 7x minus 3 multiplies 7x minus 3 to give us this. So chapter 6 will teach us that. The degree of this polynomial is 2. Leading coefficient is 49. The constant of our polynomial is positive 9. The product of binomials, 3 minus 3x squared, that is going to multiply 4 minus 5x squared. Then we will look to subtract the quantity negative x to the fourth raised to the second power. So there's a little bit of fun in here because it's giving us a flashback to section 1. We're subtracting that value at the end. We just want to remember that power to a power rule, where when we have a number with an exponent and then that is in parentheses raised to an exponent, our power to a power rule says we can multiply together those exponents to give us a more simplified expression. But the question is here, it's negative x to the fourth that's being squared, not just x to the fourth. So what again happens when you square a negative? It becomes positive. So let's go ahead and begin looking at this example here. With our simplification, which one is our higher order? Now again, PEMDAS says start with parentheses. There's parentheses everywhere. There is a subtraction here. So we're multiplying two numbers over here. So two numbers, multiply, subtract a number squared. So it's almost like this is our dividing bridge here, where we can look to simplify on this side here, and we can look to simplify over here and see if anything comes together. I'll begin with the FOIL, just because we're reading left to right. I don't know really which one's of more importance, so I'm just going to go across the board. We have the product of two binomials, so I would look to use the FOIL method. This 3 here, multiply this 4, the product of first terms, 3 times 4, we get 12. 3, multiply negative 5x squared, negative 3 times 5, 15, x squared. Positive times negative, negative. 3 times 5 times x squared is 15 times x squared, 15x squared. Negative 3x squared, multiply the 4, is negative 3 times x squared times 4, which is 3 times 4 times x squared, which is 12 times x squared, minus 12x squared. Minus 3x squared, or negative 3x squared, times negative 5x squared. Negative times negative is positive. 3 times 5 is 15. X squared times x squared. X squared times x squared. I'm multiplying like bases. I add the exponents, 2 plus 2, to get 15x to the fourth power. Now I am subtracting negative x to the fourth squared. We said here that when you square a negative value, remember, what is this negative here? This negative is a factor, negative 1. Negative x to the fourth, we could also view this as negative 1 times x to the fourth. Negative x to the fourth is negative 1 times x to the fourth. So what is negative 1 times x to the fourth? It's negative x to the fourth. It's just a way for us to view that factor, negative factor, as negative 1. So if negative 1 is multiplying x to the fourth and that's being squared, then we must square the negative 1. Negative 1 squared is negative 1 times negative 1, which is positive 1. X to the fourth squared, 4 times 2 is 8. So this becomes a positive x to the 8th power. So we are subtracting a positive x to the 8th. We are subtracting x to the 8th. So this binomial FOIL method, using our exponent rule here from 5.1, our power to a power, as well as our product to power, Now we are left with the sum and difference of these terms. A term, subtract a term, subtract a term, add a term, subtract a term. So we have 1, 2, 3, 4, 5 terms. Is this simplified? Do any of these terms share the same degree, or in other words, exponent? They all consist of the same variable x, except for this. This is known to be our constant. The largest exponent here is the x to the 8th, so that is our degree of the polynomial. But can any of these simplify together? Right here, right? I have negative 15 x squareds. I have negative 12 x squareds. So altogether, how many negative x squareds do I have? They're both negative, right? So they're going to combine to give me an even smaller negative number, right? Negative 12 is small because it's in the negative. It's less than 0. It's really small. Negative 15 is even smaller than negative 12. When combined, they're going to get even smaller, and that is negative 27. Negative 27 x squared. We have the positive 12, the negative 27x squared, the positive 15x to the 4th, and the negative x to the 8th power. So for these 4 terms that we have, the largest exponent or degree is 8, so we will move this negative x to the 8th out front. Next largest degree, positive 15x to the 4th. We're looking at the exponent, that's the next largest, so positive 15x to the 4th. Next here is the negative 27x squared. Finally, as always, our constant goes at the very end here, if there is a constant available, in this case here, this positive 12. So we see that written in the standard form for a polynomial, it is in standard form because it's fully simplified. Each of these 4 terms here stand alone because they cannot be further simplified. Their degrees are different. Degree 8, degree 4, degree 2, degree 0. Our degree for the polynomial is 8. The leading coefficient is understood to be negative 1, and the constant is positive 12.